Now this illustration is still dealing with the grounded conductor, but this time in accordance with 250.30A3D as in dog. And notice we're inserting a high impedance grounded unit between the grounding electrode conductor and where it would connect, say, to the electrode system. Now, one thing that's important kind of coming out the gate is the information right above the caption, grounded conductor. The conditions of maintenance and supervision ensure that only qualified persons will service the installation. And then that second bullet is very important. Continuity of power is required. No safety-related procedure is mentioned here at all. You got to go to NFPA 70E to get that information. And we know that if L1 went to ground in any manner, maybe you're repairing, you're working, and some way you grounded L1 out from any reasons, well, you're not going to get electrical arc there. You get it cleared real quick. You don't want it to go face to face because it could be a big problem. So that's why that OSHA, when Joe Pipkin was on the committee, said you can't put there any kind of safety-related work practices. But you'd have to use that high impedance unit for the ground conductor and say its continuity of power is required. Now that's important to that second bullet, just for your information. Now the third bullet is ground detectors are installed on the system line and neutral loads are not served by this system. You'd have to do something else. This would be feeding three-phase loads, and then notice current would go through a window, say, magnetized, and then when current returned, it demagnetized. But if you exceeded the setting, which we looked at under services in the service chapter, I believe it was chapter 6, we looked at 230.95, dealing with ground fault protection of equipment. But here we're looking at the high impedance grounded unit. We also will talk about it more in 250.36 for 1,000 volts or less. And for over 1,000 volts, we'll look at 250.187 as mentioned to the right with the call out that we would have there. So the voltage here is 480 volt to 1,000 volt, three-phase, three-wire system, only feeding three-phase loads. And of course, we have the service disconnecting means there. If it's a separately derived system, then it wouldn't be service disconnecting means. It would just be a disconnecting means. But notice, this doesn't say service equipment, just service disconnect to disconnect the power from the transformer through this high impedance grounded type unit. Now, notice that the unit's 140 ohms, just a basic little illustration, and 277 volts to ground divided by 140 would be about 2 amps flowing, which tells us the size of the high impedance ground determines the amount of current that would flow. Now, this is basic information of the grounded conductor when we ground through a high impedance grounded unit that will provide really a continuity of the power continuously on L1, say going to ground, or L2 or L3, but not a phase-to-phase fault. So that's what this figure 16-42 is illustrating, but instead of at the service location equipment, we're installing it at a location for this separately derived system supplying such power to equipment. So that's what this figure 16-42 is illustrating.